let's implement this method together. First, let's tackle the bubble down method first. We first need to retrieve the value at position I, and we're going to define this position I as the whole. And we're going to find the child, the index of the child, using this smaller child method. And we need to pass the index we want to inspect, that is going to be whole, and the value is going to be just the value. And what we do is while child is not 0, meaning that there is a smaller child, then we just need to bubble down. So we are replacing the value at the whole with the value of child. So we are exchanging the values. And here, we're defining this whole as child, like this. And we find the value of child like this. So we pass the new whole and the new the previous value like this, and we repeat this process again and again until we find the right place for this value. And at last, this whole is going to be the correct place for this value, and we're inserting this value here. So this process is bubbling down. And to bubble down, we're defining a new method, smaller child. And how are we going to implement this smaller child? We first inspect the left child first. So that is going to be 2 times the index. And if child is smaller than or equal to the self size, then we can proceed. Otherwise, we just need to return 0 because we reached the end of the list. And if child is in the correct boundary, we need to first check whether child is not self size and the right child is smaller than the left child, like this. Sorry for that. If the right child is smaller than the left child, then what we are going to do is increment the index of child. And then we compare the value of the child and the value. If that is the case, we are going to return child. There might be other ways to implement this smaller child. For example, we can just retrieve the index of child and child plus 1, the left and right children, and then compare each of them with the value and return the index of the child. So that can be another way to implement this smaller child. So up to this point, do you have any questions regarding priority queue implementation using binary heaps? All right, let's move on. So up to this point, we talked about how we can implement priority queues. First, we have a look at how we can implement priority queues using simple Python list. However, this was not very fast and efficient, so we switched to sorted Python list. And it took ON for inserting. However, find mean and delete mean took O1. And in the case of binary heap, all 3 operations became O log n. So the average time complexity is much efficient. So this is what we've discussed. And from now on, we're going to talk about the applications of binary heaps. But before we move on, I would like to mention one more thing. In fact, Python offers default heap, and you don't have to implement priority queues on your own when you're solving some problems using priority queue. So if you want to solve other problems using binary heap or priority queue, you can just import heap queue from Python. Then you can use this heap queue library to solve your own problem. So how can you use this? To use this heap queue interface, you first need to define an empty list like this. And let's say we have random ordered items like this. And when you want to insert new item to this heap, what you can do is heap queue dot heap push and pass a heap list and the item you want to push. So this corresponds to our insert method. And when you want to retrieve the mean value, then you just need to heap queue dot heap pop and pass the heap. Then it will return the mean value. Like this. So the mean value 1 is passed like this, okay? And if you already have a list of items and you don't have to run this for loop, you can use heap queue heapify and pass the list, then it is going to be heapified, and the mean value comes here. So this one looks like our binary tree using arrays like this. So it follows this implementation. So you can just use this heap queue. And I'll show you one example. Using heap queue, you can solve kth largest element using heap queue. How can you do this? One approach is first we're going to construct a max heap and add all elements into the max heap. And traversing and deleting the top element using pop or pull. And we do this for k times, or k minus 1 times. And the last item is going to be kth largest element. So this is very simple, right? You just add all elements into the max heap and delete the top element k minus 1 times, then kth largest element becomes the top element. So this is how we can solve kth largest element problem. Okay. So this is very simple. So I'll show you how we can implement this. First, we need to import heap queue. That was kth largest, but here we're going to talk about kth smallest. We receive a list of numbers. So we're going to define a heap. And for numbers in nums, we are going to heap queue, heap push to this heap the numbers. And we want to find the kth minimum value. Then what we are going to do is pop items from this heap k times. And the kth mean is going to be at the top. So it's very simple to implement. Okay. So this was one way of using heap queue or priority queue. And another application is sorting. Because we have quick sort and merge sort, we do not use heap sort that much. However, sometimes you could use heap sort. And this is going to be another PPP exercise. So what we are going to do is receiving the numbers, a number of lists like this, and it's going to return the sorted list like this. So you can just use the heap queue and try to solve this heap sort.